Now that we've reviewed the area of rectangles and triangles, we're going to jump into trapezoids and parallelograms. So what's a trapezoid? Trapezoid. Trying to make sure I'm on the screen up there. A trapezoid is a four-sided shape. This pen doesn't like me. We're not going to use that. And I've lost my other green pen. A four-sided shape. It has one pair of parallel sides and that's it. But it has exactly one pair of parallel sides. So you'll notice here's a trapezoid. Ooh, that's a really bad drawing. Pretend this side and this side are parallel. This will be your most common shape right here. It'll look like this. But you can also have trapezoids with a right angle. Or two right angles. You'll notice each of them have a parallel side and only one parallel side. Those little two dashes there mean they're parallel. So our formula for a parallelogram is going to look very similar to a rectangle, but they have two different side lengths. So this is where we're seeing the combination of the order of operations and our formulas we've seen all come together. So our formula for area of a trapezoid is 1/2 B1 plus B2 times the height. So, which is h. So B1 is going to be the base 1. B2 is base 2. And h is the height. So I'm going to draw another trapezoid down here. Draw a little bit bigger. And then we're going to label these sides. Now, like in a triangle, we don't care about these funky sides. We only care about the two that are parallel. So this one here is going to be 6 inches. This one here is going to be 8 inches. And then you'll always see the height. Anytime you have to find the area, you'll see the height labeled. And our height is going to be 5 inches. So now you're saying, Mr. Spencer, I see there are two bases, even though one's in the air and the other's on the bottom. Does it matter which one is which? It doesn't. Because of the way our formula is set up, you can switch them, and because they're both in the parentheses, you'll end up with the same answer either way. So I'm going to call this one up here B1. I'm going to call this one B2. And of course, the height is the only one up here, so that's our H. Then all we have to do is substitute those in to our formula. So I'm going to go ahead and rewrite our formula over here. 1/2 base 1 plus base 2, close the parentheses, times the height. Now, I'm going to rewrite our equation. Sorry, I just got a voicemail from Dr. Demps. Rewrite it with our variables substituted in for the letter. 1/2 times 6 plus 8 times 8. Now this is where the order of operations we've been talking so much about this year comes into play. If we remember parentheses, exponents, multiplication, division, addition, and subtraction, we know that what's in the parentheses has to be done first. So we're going to do 6 plus 8, which is 14. Then we have 1/2 times 14 times 8. So then we just have multiplication left, and we're going to work from left to right. 1/2 of 14 is 7. Then we have 7 times 8. Oh, I'm off the screen. I am so sorry. Then we have 7 times 8, and I know 7 times 8 is 56. Now, please don't forget we have our units, and they are our units squared. So it's 56 inches squared. Awesome. I'm going to give us another trapezoid. I'm going to leave it here for just a minute. Make sure I'm not going too fast. Remember, you can always pause the videos if I am. And then I'm going to give us 2 practice ones to do, and then we're going to solve them. So let's draw out 2 trapezoids. This one will be 8 inches by 10 inches. And the height here is going to be 5 inches. And then we have this second trapezoid over here. One thing I love about trapezoids is you can have some really funny looking trapezoids. They can be really, really stretched out or really tall. This one over here, we're going to call this one 7 inches, 11 inches, and then 3 inches tall. All right, take your time, solve this here. Pause it, and jump back in when you're ready to go.